Hello everyone, this is Teacher Joe, and we meet again. Last time we talked about number puzzles. I wonder how much you still remember. I want to emphasize again that number puzzles are a very important topic in both 3rd and 4th grade. Okay, if you haven't mastered them yet, or haven't clarified the way of thinking, remember to go back and review. In class, we help sort out the key points for solving these types of problems. Once you grasp the key way of thinking, everything naturally becomes clearer. Okay, with a little practice, this will be no problem at all. So what are we talking about in this lesson? We're back to talking about calculation tricks. This lesson is about calculation tricks for integer multiplication and division, Part 1. I call it Part 1 because everyone has learned less about division so far, so we'll have more calculation tricks for multiplication and division in 4th grade. So what's in this lesson? We're going to talk mainly about some calculation tricks for multiplication. Now speaking of calculation tricks, we've had a lesson on this before for integer addition and subtraction. I wonder how much you remember. Making a whole number and other principles, do you remember any of it? If you don't remember, you need to go and review. If you do remember, then I'll give you a thumbs up. You're pretty sharp, that's quite good. So we all should remember the concept of making a whole number. What do we use to make a whole number? We use some friend numbers in addition, like 1 and 9, 2 and 8, 3 and 7, 4 and 6, and 5 and 5, right? These friend numbers can make a whole number, which makes the calculation easier. Well, multiplication actually has friend numbers like this too. So in the first half of this lesson, we're going to talk about which pairs of friend numbers exist in multiplication. Here comes the first one. Here it comes. Who is the first pair of friend numbers? 25 times 4. Oh, some of you already know. 25 times 4 equals 100. I don't need to calculate that for you again, do I? If you didn't know before, you know now. If you already knew, now you know it even more deeply. Anyway, this is the most important pair of friend numbers in multiplication. 25 times 4 equals 100. So we said the principle of making a whole number is to make a multiple of 10, 100, or 1,000, because that makes it easier to calculate, right? And since 25 times 4 equals 100, this pair of numbers can make a whole number. It's an essential friend number pair for making whole numbers in multiplication. So you must know it. You must. So how do we use it? When we're solving problems. When we're solving problems, this is how it works. For example, when we do this problem, the first one, 25 times 24, when you see the number 25, you need to look for a 4. You have to find a 4, because its good friend is 4. If there isn't one, you have to make one. If there is one, then we just use it directly. For example, in 25 times 24, there is no 4. What do? No 4, no problem. I'll see if I can get a 4 out of this 24. 4 times 6 is 24. So you just split the 24 into 4 times 6. That's the idea. And just like that, it has found its good buddy. Come on, once these two are done, it's 100. 100 times 6. That's 600 directly. It's that simple. It's that simple. Okay, so when you're doing these, you see, I've written out the process, right? I hope that when you do them, once you see the 25, and after you get proficient, you can do it with mental math. Okay, so you have 25 times 24. You split out a 4, and you're left with a 6. So that's 600. When you split out a 4, this part becomes 100. Whatever is left on the other side, that's how many hundreds it is. If you're left with 16, it's 1600. It's that simple. Understand? For example, when we're doing the second problem, 28 times 25. Hey, there's a 25. We need to find its good friend. Who is it? 4. So in 28, how many 4s are there? What times 4? 4 times 7 is 28. See, that's it. And just like that, 4 times 25 is another 100. Okay, you're left with a 7 on the other side. 7 times 100 is 700. It's that simple. It's that simple. Okay, the third one. The third one. Some of you might look and say, hey, something's not right. Teacher Joe, 25 times 14. There's no 4 here. 14 can't be made by 4 times anything. So what do? No problem. If it doesn't work, no problem. Let me introduce you to its little brother. 25 times 4 equals 100. So let's get to know 25 times 2. Let's get to know it. If times 4 equals 100, then times 2 equals 50. So for 25 times 2, we don't need to memorize it by rote. If you remember that 25 times 4 is 100, then isn't 25 times 2 just 50? So when we're doing a problem like this, and we can't find a 4, we can look for a 2. 2 is also a good friend. Maybe not the best friend, but still pretty good, right? For example, in this problem, 25 times 14, I can't find a 4, so I'll find a 2. 2 times 7 is 14, is that right? And so 25 times 2 is 50. Then it becomes 50 times 7, which is 350. See, it's also very simple. Multiplying by 50 is also easy. Do you understand what I mean? So this is the first group of friend numbers we're talking about. 25 times 4 equals 100, and 25 times 2 equals 50. All right, do you see this page? There are 6 problems here. Come on everyone, press pause, get a piece of paper and do them. Time yourself, see how long it takes you to finish. When you're done, unpause and come back. Then you can watch me explain. Okay, did I make that clear? So you should be pressing pause to do them now. Calculate them yourself. Get some practice. Okay, you're done practicing and you're back. Okay, let's pretend you've all finished practicing. We're back. Wow, you guys are amazing. You did a great job. I don't actually know how you did. But okay, let's get started. I'm coming. Let's see if you're as fast as I am. 25 times 36. I pull out a 4. 4 times 9 is 36. There we go. This part is 100, so it's 900. I don't even want to write the 100. Fine, I'll write it so you can see clearly. Okay, next. 12 times 25. I'm 25. I need to find a 4. I need my good friend. 3 times 4 is 12. So this is 100 times 3. 300. 25 times 16. 25 times 4 times 4 is 16. So 100 times 4 is 400. Right. Actually, when you get fast at this, you can really do it with mental math. You really can. Come on. 32 times 25. I'm 25. I need to find a 4. Yes, there's a 4. 4 times 8 is 32. My buddy makes 100. Hey, good buddy makes 100. 800. Right. Hey, 25 times 6. There we go. This time you can't get a 4 out of 6, right? 6 divided by anything doesn't make 4. And 4 times anything doesn't make 6. So let's look for a 2. 25. This time I can't find a 4. So we'll settle for the next best thing. Let's find a 2. 2 times 3 is 6. So 25 and 2, that's 50, right? This is 50. That's okay. We're still pretty good friends. 3 times 50, that's 150. You see. The last one. 25 times 18. You can't get a 4 out of 18 either. So let's find a 2. 2 times 9 is 18. That's a 50 times 9. 5 times 9 is 45. So 450. All right. Come on. This is the first group we talked about. 25 times 4 equals 100. 25 times 2 equals 50. Let's summarize it. You must always remember to summarize what you've learned and take notes. 25 times 4 equals 100, and the one that goes with it, 25 times 2 equals 50. Okay, this set, the first one is easy to remember, and the second one is even easier. Okay, 2 pairs of good friends, but really it's just one pair. Okay, the second one is its little brother. Alright, so we're done with the first group. We're past it, done. Let's move on to the second group. Who's next in the second group? Hey, everyone should be quite familiar with the first group. For the second group, some of you might not be so familiar. Let me write it down. 125 times 8. This equals 1000. Right, because a core logic of calculation tricks is to make a whole number, right? You either make 100 or you make 1000. In multiplication, who makes 1000? It's this one. 125 times 8. Some of you might not believe it. Okay, since it's a big number, since it's big, I'll calculate it for you on the side. 5 times 8 is 40. 2 times 8 is 16. Plus 4 is 20. 1 times 8 is 8. Plus 2 is 10. See, 1000. No problem, right? I didn't lie to you. Okay, your teacher Joe is honest and fair to everyone. Okay, honest teacher Joe. Alright, 1000. To be honest, you don't need to memorize this by rote either, right? Just do it a few times in a row, and you'll remember it. There's no real memory cost. When you learn math with teacher Joe, nothing requires you to memorize it by rote. It's all about understanding. Once you understand, you'll naturally remember it. Okay, understand it. Do it a few more times, and you'll naturally remember it. Okay, so the second group of friend numbers is 125 times 8 equals 1000. So if 125 times 8 equals 1000, what do I do when I see 125? I have to go look for an 8, right? Every day it has to go find 8 to play with. Okay, so if I need to find an 8, and I have 16 here, to get an 8, I need 2 times 8 is 16. Is that right? Hey, just change the 16 directly into 2 times 8, and you're done. This is 2 times 8 is 16. So 125 and 8 come together to make 1000. Then 1000 times 2 is 2000. 2000, right? 2000. No problem. Let's think again. Let's look one more time. 125 times 8. 125 finds 8, makes 1000. Then times 2 is 2000, right? Take another look. No problem. No problem. I'm moving on. The second problem. 32 times 125. See, there's a 125 again. If there's a 125, I want to find an 8. I have a good relationship with 8. So now you have 32. How do you get an 8 out of 32? 4 times 8 is 32, right? It's from the multiplication table. Isn't it 4 times 8 is 32? So 8 and 125. This thing is 1000 again. Times 4 is 4000. 4000. Is that okay? Okay, good. The third problem. The third problem. Some people might say, buddy, I see the 125. We're pretty familiar. I want to find an 8. Hey, you can't get an 8 out of 12. What times 8 equals 12? Nothing. Nothing. What do we do? Come on. This time, I told you, when you learn with me, you don't need to memorize by rote. Your thinking can be trained and developed, right? Think back. Up above, when you couldn't multiply by 4, who did you turn to? 25 times 2 equals 50, right? 25 times 2 equals 50. So isn't it the same now? 125 times 8 equals 1000. So if I write 125 times 4, it's just 500. Does anyone not believe me? I don't need to write out the vertical calculation again, do I? I don't need to write it out again. No one disbelieves me, right? All right, my friends. No one disbelieves me. Okay, come on. 125 times 4 equals 500. You don't need to memorize this second one either, because if you can remember that 125 times 8 equals 1000, you'll know that 125 times 4 equals 500. So it's the same logic as with the 25. When we see 125, it's best to find an 8. If you really can't find an 8, come on, a 4 will have to do. I can't get an 8 out of 12, but I can at least get a 4. 3 times 4 is 12, right? Isn't it 3 times 4 is 12? So 125 times 4, that's a 500. Hey, so that becomes 125 times 4 is 500. You see, 500 times 3. 3 times 5 is 15. With 2 zeros is 1500. Right, 500 times 3. Yes, right, 1500. 3 times 5 is 15. 2 zeros, 1500. Okay, so this is the second group of friend numbers. 125 times 8 and 125 times 4. 1 makes 1000. And 1 makes 500. Got it. Okay, if you all understood, come on, let's do it one more time. What do we do? Press pause and write them yourself. Press pause and write them yourself. Okay, alright, let's all write them down, because this is pretty fun. After you practice this, when you go back and do your own problems, if you encounter a 125, you'll be faster too, right? What a happy thing that is. Okay, so I'm pretending again. Pretending again. We're playing house. I'm pretending you've all finished. Okay, even though I don't really know. I don't know, and I don't dare to ask, but I just feel like you're done, and you did a great job. Fantastic. Okay, fantastic. So now it's my turn. Okay, my turn. Let's see how I do compared to you. Let's go. Let's go. 125, right? I need to find an 8. I'm buddies with 8. We're good buddies. 125. I see it. I look for an 8. 24. 3 times 8 is 24. 1000 times 3 is 3000. Done. 64 times 125. There's a 125. I'm good buddies with 8. Come on. 64. 8 times 8 is 64. So that's a 1000 times 8. 8000. Right. Next. 125 times 56. I'm good buddies with 8. Is there an 8 in 56? 7 times 8 is 56. So 1000 times 7 is 7000. 72 times 125. 125 looks for an 8. Is there an 8 in 72? 8 times 9 is 72. There you go. 1000 times 9 is 9000. Next. 28 times 125. 125 looks for an 8. Is there an 8? There's no 8 in 28. Right. What times 8 makes 28? Nothing. Can't find an 8. What did we say to do? Find its little brother. Find 4. It's on good terms with 4 too. Find 4. We can use 4. Is there a 4? 4 times 7 is 28. Right. So this. Hey, 125 times 4 is 500. Don't get it wrong. Don't write 100. 7 times 5 is 35. With 2 zeros is 3500. Next. 125 times 36. Look for an 8 first. What times 8 is 36? Nothing. So look for a 4. 4 times 9 is 36. So it's times 4 then times 9. Let's go. 125 times 4 is wait. I told you not to get it wrong. I told you not to get it wrong. It's 500. Don't get it wrong, team. 500 times 9. 5 times 9 is 45. 4500. Alright. So we've finished practicing this set with 125. We're invincible. Come on, let's summarize. Let's go. Come back. When you learn something, you have to summarize it. Hey, don't learn something at the beginning and forget it by the end, right? Summarize. Take notes. Deepen the impression. Actually, if you listen carefully in class, you don't even have to do much after class. You'll naturally remember it. Isn't that right? 125 times 8. Good friends. 1000. Do you really need to memorize that by rote? I don't think so, right? It's very simple. You just remember it. Once you know 125 times 8, then times 4 is just 500. You don't need to specially memorize that or anything, right? Math still relies on understanding. In Teacher Joe's class, nothing requires you to memorize by rote. Actually, for many things, once you truly understand them, you'll naturally know how to do them, right? And even if you forget one day, you can still think back on your own. Hey, how did I learn that? What was the process? Oh, I need to make a whole number. Make 100. Make 1000. To make 100, it's 25 times 4. To make 1000, it's 125 times 8. And then you have 100 and 1000, and also 50 and 500. They are made by multiplying by 2 and 4, respectively. They're the little brothers, right? Hey, these two groups are the friend numbers in multiplication. What can they help us do? They help us make a whole number, right? This idea of making a whole number in calculation tricks. Hey, it's everywhere. Actually, all the way until you're in higher grades, in middle school, in high school, it's still useful. It's still useful. It's always about making a whole number. Calculation tricks are just making a whole number. It's a base 10 system. If you can make a whole number, you can definitely do a calculation trick. Alright, so we'll stop here for now with these friend numbers, but we're not done. Next, I want to teach you two more. Hey, I think they're especially good, especially useful, and they also require absolutely no rote memorization. Two calculation trick buddies. Okay, the first one is multiplying by 11. Multiplying by 11. Multiplying by 11. How is that easy to calculate? Because we find that for any number multiplied by 11, for example, let's just write 1 out. 12 times 11. That's 132. Right. Let's write another one. 32 times 11. That's 352. Hey, have you discovered a pattern? For any number multiplied by 11, it's like you take the original number and write it twice, side by side, but staggered. Did you see it? 12 and 12, written twice, staggered by one space. Hey, 32 and 32, written twice, staggered by one space. See? Hey, that's the pattern. That's its pattern. So let's look a little deeper. So what if, pay attention, what if the two digits in the middle, when added together, don't require carrying over? Can we just write the answer directly? What do I mean? For 12 times 11, you just look at the two digits, 1 and 2. If 1 plus 2 doesn't require carrying over, then isn't their sum just the number in the middle? In other words, what do? You put the 1 in the front, the 2 in the back, and 1 plus 2 equals 3, which you write in the middle. But this is not something to be memorized by rote. I've said it. If you're going to memorize it by rote, you might as well not learn it. Okay, if you're going to force yourself to memorize it, just don't learn it. I've heard some teachers talk about a noodle method or something. I never teach that. I never teach that. For this, even if you forget the pattern, what can we do when we multiply by 11? You quickly take the number you're working with and write it twice, staggered. Write it once on top and once below, staggered by one space, and then just add them up quickly. This is especially useful when there is carrying involved. I require everyone to write it out twice when there is carrying, because it's very easy to make a mistake. For example, 56 times 11. In the future, how should we write this? You don't need to write out the words 56 times 11, as long as you are multiplying by 11. Hey, you just write 56 twice, staggered by one space. See? Just like that. Hey, that's a 6. This is an 11, so you carry a 1. That's a 6, and you're done. The steps from before, like for 32 times 11, are eliminated. When there's no carrying involved, well, if you think you can remember it after hearing it once, then remember it. If you listen and you can't remember it, then just write it out twice, side by side. Right. Hey, side by side, 32, 32, written twice. Actually, after you've written it a few times, you'll discover the pattern. For 32 times 11, if 3 plus 2 is just 5 and doesn't require carrying, then 5 is in the middle. The sum of the two digits is in the middle. Look, their sum is in the middle. Put the 2 in the back, the 3 in the front. It's really just from writing 32 and 32, like this. Let's not memorize this by rote, okay? Even if you forget one day, what should you remember about multiplying by 11? Write the number twice, staggered by one space, and just add them up. Okay, so this way, actually, multiplying any number by 11, no matter how big, can become faster. For example, 156 times 11. We just write 156 and 156, staggered by one space. Right. Then, this is a 6, a 1, a 7, a 1, and you're done. Just like that. A 6, a 1, a 7, a 1, and you're done. Okay, there's another page after this. There's another page. You can press pause and practice on your own. After you've practiced, we're back again. Okay, you've practiced, and now we're pretending you're back. I'll write a few more. If some of you are still not very proficient, I'll write a few more, and we can look at them again. For example, 11 times 44. We first look at 4 plus 4, which equals 8. It didn't require carrying over, So 8 is the number in the middle. You write a 4 on one side and a 4 on the other. The back number goes in the back, the front number goes in the front, and you're done. Of course, if you say you don't want to remember this pattern, and you can't, that's okay. You can just do it this way. 44, 44. See how simple? You get 484. It's the same, right? And when there is carrying involved, I don't even want you to try the other way. If, say, 4 plus 8 equals 12 and you have to carry over, then we must write it out like this. Writing it this way is both fast and accurate. You see, if you just memorize some jingle and you accidentally calculate it wrong, I'm telling you, you'll have no one to blame. The essence of a calculation trick is to get the right answer faster. We can't change that goal, okay? So when you all learn this multiplying by 11 trick, you must not take the wrong path, okay? Memorizing some jingle is unnecessary. For 65 times 11, just write 65 twice. Look, this doesn't even take 2 seconds. Does it even take 2 seconds? Right. Then you have 715. It's clear at a glance. It's actually faster to calculate this way. It really is. 87 times 11. Look, this comes right out. 957. Right. 124 times 11. Write it in 2 rows. Staggered. 1364. 872 times 11. Write it in 2 rows. Staggered. 9592. And you're done. Okay, so that's multiplying by 11. Let me say it again. There is no jingle to memorize here. Okay. In fact, you don't even have to remember the pattern I mentioned earlier. Just remember that to multiply by 11, you write the number twice, staggered by 1 space. Okay. It's guaranteed to be fast and accurate. In all my years, I think this is the best method. Please don't take any detours. Okay. Because I know some teachers teach it that way. Okay. On this, you have to listen to me. Okay. You must listen to me. Because if you just memorize those jingles, you have one jingle for one number. With so many numbers by the time you get to 5th and 6th grade, to middle school, to high school, right? If there are 10,000 numbers for you to remember, can you remember them all? Are you going to memorize 10,000 jingles? That's impossible, right? Impossible. So we just need to remember this most fundamental method, and there will be no problem. Even if you forget the jingle, this multiplying by 11 method, isn't it just like vertical multiplication? Right. You just write the number in 2 rows, not side by side, but staggered, and then you just add them up, and you're done. Right. So what this means is that we've saved the steps from before, like writing out 12 times 11, and so on. Right. That part can indeed be skipped. Okay. Just remember this pattern. Remember this principle. Don't remember any jingles or ultimate moves. Alright, so that's all for multiplying by 11. We're done with that. I want to teach one last trick. Okay. This one is also very useful. There's no memory cost, no jingle, and nothing you need to specially memorize. Basically, after you hear me explain it this one time, you'll remember it for the rest of your life. I'll teach you all this kind of trick. Okay, what is it? It's some number 5 times some number 5. Look, it's something 5 times something 5, not 05. See how I'm expressing it? It's a 5 with something in front of it, times another something 5. Okay, actually this is about the square of numbers ending in 5. Some of you might not understand what a square is, so I don't want to use that term. If you don't understand what a square is, it doesn't matter. Just remember that it means the 2 numbers are the same. This is called a square number. 15 times 15. 25 times 25, 65, 105 times 105. Do you hear me? This requires the last digit to be a 5. As long as you see this kind of number, we can use a calculation trick. So how do we do it? There's no jingle, no other messy stuff. This is very simple. Look, for any something 5 times something 5, if the 2 numbers are the same, you just have to remember that the last 2 digits of the answer are always 25. Then for the number in front of the 25, look, what is the number in front of the 25? You just look at what's in front of the 5. In front of the 5 is a 1, right? So you take 1 and multiply it by the number that is 1 bigger than it. So multiply it by 2, 225. If you didn't see it clearly, no problem. We'll do 2 more, and then you'll see it clearly. So for example, what about 25 times 25? You see the last digit is a 5, and the 2 numbers are the same. In that case, the last 2 digits of the answer will definitely be 25. You just need to look at the number in front. So what is the number in front? It's the 2 in front of the 5. The number before the 5 is a 2. So you take 2 and multiply it by the number that is 1 bigger than it. So 2 times 3 is 6. The answer is 625. Okay. Hey, still don't get it. Let's do another one. The last digit is 5, and the 2 numbers are the same. So it's directly at 25 at the end. And the number in front, you find the 6 in front of the 5. So that's 6 times 7, the number 1 bigger than it. 6 times 7 is 42. See, it's 4225. So this pattern is also very simple. You don't need to memorize it by rote. Basically, after I've explained it, okay, you probably won't forget it until after you graduate college. Right. There should be no problem. Okay, get a feel for it. Right. This is not something you need to specially memorize. As long as you've heard it this one time, you'll basically know it. You'll know it and you can use it. Okay. Look, this one again. The last digit is 5. The last digit is 5. The two numbers are the same. Come on, the end is 25. So what's in the front? Some students might ask, look, the number in front of the 5 is 10. What do we do? Then it's just 10. So it's 10 times the number 1, bigger than 10, which is 11. That's 110. See? So this is 11025. Hey, they're all done like this. Okay, they're all done like this. This time everyone should understand, right? Hey, everyone should understand. For those who understand, press pause, do this one on your own, and then press pause and come back. For those who don't understand, we'll do this one together right now. Okay, we'll do this one together right now. It's very simple. Look, 55 times 55. The last digit is 5, and the two numbers are the same. I'll write down the 25 first, then for the number in front, what 5 is it? 55. So that's 5 times the number 1 bigger than it, which is 6. 5 times 6 is 30. 30 25. 75 times 75. Look, the last digit is 5, right? So that's 25 at the end. Then for the number in front, you look in front of the 5 is a 7. So that's 7 times 8, which is 56. So it's 5625. Understand now, 85 times 85 is the same. Hey, this ends in 25. And the number in front is 8. 8 times 9 is 72. I won't write the step below. You should be able to understand, right? Where this 72 comes from. It's from taking this 8 and multiplying it by the number 1 bigger than it. No problem, right? Okay, 95 times 95. Both end in 5. The two numbers are the same. 25 at the end. And in the front, it's 9 times 10, which is 90. 90 25. Okay, 115 times 115. 25 at the end. This part is 11 times 12. 11 times 12 is 132. 13225. Okay, we just learned that. 12 times 11 is 132. You think about it in your head. 12 12 staggered. 132. 995 times 995. The last digit is 5. First, write a 25. In the front, you see, it's 99, right? So that's 99 times the number 1 bigger than it. 100. 99 times 100 is 9,900. Right, so that's 990025. 990025. Right, 9900. You just write it like that. It's very simple. In the future, for all these squares of numbers ending in 5, or as we call them, multiplying a number ending in 5 by itself, you can all learn this, okay? You don't need to memorize it by rote. You don't need to memorize it. Now, apart from this multiplying by 11 trick and this squaring numbers ending in 5 trick, besides these two, all those other various jingles, okay, all those so-called ultimate moves, all those strange things, I want you to just not learn a single one of them. Because for the rest of them, I can responsibly tell you that once you get to 5th and 6th grade, to the higher grades, to middle school, to high school, they will definitely be useless. Things like giving you a jingle for any 2-digit by 2-digit multiplication, it's completely meaningless. Okay, everyone, on this matter you have to trust me. Because Teacher Zhou taught high school for many years. Okay, on this, you just listen to me. We just need to remember these two. Okay, these two are both very simple and have no real memory cost. Go back and review this multiplying by 11 trick, how it works, and this trick for squaring numbers ending in 5. Okay, let's also summarize. So besides the friend numbers, we learned one more, multiplying by 11. And we also learned about something 5 times something 5. After you learn about squares, you'll know this is called squaring a number with a ones digit of 5. Okay, these two. So if you've learned all these things, finally, let's apply them to a few integrated problems, and then we can bring this lesson to a close. What kind of problems? The kind with multiple numbers being multiplied together. The principle for multiplying multiple numbers is very simple. It's the same as for addition and subtraction. It's called making a whole number. Actually, the core logic of calculation tricks is making a whole number. 4 times 11 times 25. Look, we don't even have to split this one ourselves, right? The problem has already split it for us. So naturally, it's 100 times 11, which is 1100. Okay, 125 times 13 times 8. Look, you don't have to split it yourself. The problem intentionally separates them. But we have to be able to see it, right? We have to group the good friends together. So this is the same as 13 times 1000, which is 13,000. 13,000, right? Okay, next one. 25 times 32 times 125. What do we do with this one? It's the same idea. When you see 25, you have to think of 4, right? So if we're thinking of 4, is there a 4 in 32? Yes, there is. 4 times 8 is 32. Hey, isn't that a coincidence? Right. Isn't that a coincidence? 4 times 8 is 32. So what a perfect fit. These two buddies get together to make 100, and these two buddies get together to make 1,000. 100 times 1,000 is 100,000. How many zeros? 5 zeros. 1, 2, 3, 4, 5. Let's count. 2 zeros. 3 zeros. 1, 2, 3, 4, 5. 5 zeros, no problem. Okay, so how do we do this kind? The last one. 5 times 5 times 11 times 16. How do you play this one? Look, 5 times 5 is 25. You have to be sensitive to this. Now it's 25 times 11 times 16. I'm 25. I want a 4. There's no 4 in 11, but there is a 4 in 16. 4 times 4 is 16. Hey, 25 finds a 4. That makes a 100. So this is the same as 100 times 11 times 4. From here you can calculate it any way you want, right? That's 4,400. Yes, 1100 times 4 is 4,400. Or you could do 11 times 4 first to get 44, then times 100. That's also 4,400. Okay, from here on you can do it however you like. So this just means that when we encounter these longer expressions, everyone should also be able to, hey, find the friends and simplify the calculation. Okay, so for today's content, we'll stop here for now. As for division, because we haven't learned much about division yet, still relatively little, so in 4th grade we will have a second lesson on multiplication and division. In that lesson we'll combine multiplication and division together, and we'll tell you what kind of calculation tricks there are for that. Okay, so that's all for today's content, the friend numbers and the logic of simplifying calculations. The core logic is to make a whole number, the same as with addition and subtraction. You'll increasingly find that actually, math is all interconnected. In the end, it's all about integrating and understanding everything. You can't learn each thing as if it's brand new. Okay, and then I taught you 2 extra tricks that, hey, don't have much of a memory cost and are easy to calculate. One is multiplying by 11, and the other is something 5 times something 5. So for these, everyone should go back and review them well. And that's it for today. We'll see you next time. Bye-bye.